So here we are back at the Ubuntu VM, and now let's play a little bit around with this Android debug bridge. So therefore I'm having this real device over here and I'm plugging this in via USB. Something I guess you have not seen before, right? And smartphone being plugged in via USB. Okay, so it seems like it has a connection. Perfect. Now let's open a terminal and let's execute this command adb shell. And here we can see daemon is not running and it's being now started on the TCP port 5037. We can also see daemon has been started successful and we are now on this device. Walleye, that's the code name for this Pixel 2 device. Everything works perfectly fine. So let's also have a look into this service. If you open a new terminal, we can use netstat with those parameters. I put this on the left to make this a little bit larger. Let's zoom out. There we go. Okay. Here we can see we've got something on localhost listening, and this one, yes, this is the ADB server right now. So this one is listening on port 5037 on our localhost interface. Let's also observe this connection maybe. So let's have a look into this one with Wireshark. Let's see. We want to listen on this loopback interface. Yes, I have to start it with root privileges. Let's do this. All right. And now if we open a new terminal, because you can never have enough of them. And if you're now typing this command adb shell, so this command will be forwarded to the ADB server, which is sending this to the device, which executes it and provides us back the result, right? Let's see. All right, and we have seen a lot of packages appear in the background. Let's have a look into them. Okay, let's scroll up. So here we've got it right now, and we can do, I guess, a right click, follow TCP stream. So then we have it, and I mean, yes, okay. As already mentioned, it's a text-based protocol, and yeah, there isn't that much going on over here, but now you have also seen this right now. So this one is, I guess, the request, and that's the response. So we get an OK back. All right. Let me see. If you're not using this stream, I mean, we could also use different streams. Yes, then we can see a little bit more action is happening over here. So within this stream, we also got a second one, a third one in this case. Okay, I guess, yeah, you can have a look into this one. Here's the result right now. All right, but for now, enough from this one. So yes, we have seen the service running on our system. Now let's also have a look into the service on the device. Is there really a service running? So let's figure this out. ps-a, and I guess, yeah, these are a little bit much. Let's clear this. So let's search for ADB, and let's also get 2 lines after and 2 lines before, so that we're not just having one single line in here. And here we have it. This is the ADB daemon running on this device. Okay, and yes, these are the 3 components interacting with each other. So we've got our ADB daemon on this device. We've got our ADB server, I guess already gone. Our ADB server running on localhost. So let's do this once again. This one, and also our ADB binary, this one over here. Alrighty? Okay. Next, let's make this a little bit more challenging. So let's add another device and then interact with those devices. And therefore, we are using the emulator. So let's see which devices we've got available. Nexus 6. This, by the way, was the moment when I realized, oh, we need some root privileges, and this Nexus 5 with this Google Play Store does not have root privileges. Therefore, I switched to this device, which works perfectly fine during this whole course. Okay? All right, so let's start this one. Emulator, add, and then this name. Okay? And here we have it right now. Cool. If we now open a new terminal and typing in adb shell, then we're getting an error because we are now having our real device, this one being connected, and this emulator. And the ADB server does not know which device we are talking to right now. So therefore we have to provide the serial number, and we can get this with ADB devices. Got a little bit too exciting right now. Here we have this, perfect. So this is the serial number of this emulator, and this is the serial number of our Pixel 2 device. So if you want to execute a command on the Pixel 2 device, we have to use ADB-S, serial number, and then, for example, shell. Here we can see, yes, we are now on Walleye, which means this is, yeah, as already mentioned, I guess you have heard it quite often right now. It's the code name of this Pixel 2 device. Okay, I stop it right now. So if you want to execute a command on this emulator, which serial number do we have to use? Well, it's really this one over here. So this whole string, ADB-S, shell. There we go. So now we are on the emulator. Let's see. I mean, not sure if you have remembered all those processes and IDs, but this is now the emulator right now. We can also see x86. Okay, this is how we can handle multiple devices. Now let's also have a look into a TCP IP connection. So let's boot up our virtual machine, our Android x86 virtual machine, and make a connection to this one. Because there we might have some trouble doing this. And this is something I really would like to show you. So let's boot this up. Okay, so here we have the virtual machine now up and running. And if you want to make a connection to this one, we need to have the IP address. And this could be already the first issue. So this virtual machine is using a network adapter. In my case, I have set this to NAT. And if you want to connect to the virtual machine from our Ubuntu VM, we need to be in the same subnet. And so please make sure that both machines are sharing the same network adapter. It could be NAT or it could be also host only. This doesn't really matter. It just has to be the same. All right? Okay. After eliminating this error, we can now fetch this IP address from this virtual machine. So how can we do this? Well, there's already an installation being installed which assists us on this. So if we drag this upwards, then we can see we've got a terminal emulator. And this one is super handy because this one is really a terminal on our Android x86 virtual machine. So we can now use a command, for example, IP address, and then we get those interfaces. And here we can see we've got a loopback interface, and the IP address should be normally being assigned to this WLAN 0 interface. And this sounds now a little bit ridiculous because it's a virtual machine. How could this one have Wi-Fi? And yes, it does not have Wi-Fi access or not real Wi-Fi access. But it's using a virtualized Wi-Fi to connect to the network adapter. So in my virtualization, I have chosen a network adapter from type NAT, and this one is now providing a virtual Wi-Fi for this virtual machine. All right? Maybe not, but I would suggest let's have a look into this one. Okay, so let's get into the home menu, upwards one again, and then within settings, let's see. Okay, within network and internet, we can now see Wi-Fi has been turned off, so it cannot work this way. Let's enable it. All right, let's enable it here. And now it's searching for Wi-Fi networks, but of course, not the one around us, so the physical networks. And here we can now see it has found a virtual network. So let's connect to this one. Okay, so now we can see it's connecting and obtaining IP address. Perfect. So this one is now using a virtual Wi-Fi, which is using the network adapter to communicate with the outside world in case of NAT. Or if you're using a host adapter to at least communicate with one network interface. All right? Okay, so perfect. This means we should now have an IP address. Let's see. Back to the terminal. Let's repeat the last command. There we go. We can see 172.16.240 and 133. If everything works out, then we should just remember the last three numbers over here because we should be in the same subnet because we are using the same network adapter on our Ubuntu VM. So we just have to remember the last octet of this IP address over here, 133. Let's get back to the Ubuntu VM and then finally let's make our connection to this one. So, okay, we have to log in once again. Okay, and now let's see, ADB devices. We still got our real device and this emulator, okay. And now if we are using ifconfig, yes, we are within the same subnet. So we can now use ADB connect 172.16.240.133. So this one is the IP address of our Ubuntu VM, and 133 is the IP address of our Android x86 virtual machine. All right, let's see. And we are now being connected. Nice. If we are executing ADB devices once again, here we can see we've got now 3 devices. This one, our Android x86 VM, our emulator, our real device. All right. So now we have been, 3 devices attached to this one. Let's make this a bit larger. Okay, let's clear the screen. All right. So now if you want to make a connection to our Android x86 virtual machine, what is the serial number? I mean, we are having the IP address and it seems like a port in here. Is the IP address really the serial number? Well, let's find out. ADB shell, no, not this way. ADB-S, serial number, and then the command. Let's see, 321. Perfect. Now we've gotten a different prompt, x86. Perfect. So now we've got the 3rd prompt right now. And this is now the prompt for our virtual machine, our Android virtual machine. We can verify this by typing in ifconfig, because here we should get the IP address of our virtual machine, which is 133. Let's see. And yes, here we have it. Perfect. So this is how we can interact with all the devices. But to be honest, this makes things unnecessarily complex. So what I like to do is having one device attached to this machine where I'm working with. And it's not really required most of the time to have multiple devices at the same machine right now. All right. But nevertheless, you are now well prepared to interact with everything. Okay? Perfect. Then let's get back. Okay, so we have seen the inner working of ADB. We have also seen how to handle those connections. Oh yeah, one thing which is also pretty cool, if we enable or allow this access to a certain device, for example, this real device, you remember this pop-up, this one? Yes, you do, of course. So this is some kind of acceptance that this laptop is being allowed to connect to this device. And these information are being stored on our local system and also on our device. So within the home directory, we've got a hidden directory. Let me show this to you, but don't tell anyone, okay? So if we press Ctrl H, then we can enable or see all those hidden directories. They've got a dot in front on a Linux system. Let's hit Ctrl H once again, that no one sees them, okay? So now if we are entering this Android directory, which should be also available on your system, then we can see we've got ADB key and ADB key pub. Okay, so let's print this file out maybe. And this one is now the public key of our ADB key. So it sounds a little bit complex, but this is simply just asymmetric crypto. I know, simple and crypto in one sentence, are you crazy? But I also do not want to start talking about cryptography right now. So this is a topic I'm talking about within the man in the middle section when we have a look into HTTPS. Right now, I just want to show you, okay, we are having here a public key and we are also having the corresponding private key. So let's also print this one out. This, by the way, should kept private. I mean, for me right now, it's way too late, but you should keep your private key private, because if someone has this key, this person can connect to those devices. I mean, right now for me, it's not a big deal because these are testing devices or emulators running on my local system. But if you're using a private phone, which I also do not recommend, but if you're using it, then this could be really bad if you lose this key. So someone with a USB cable or also on the same network can get access to your device, okay? So keep your private key please private and do it not the way I do right now. So just forget about this. Okay, so this is now my ADB key and we can also verify this key on the device. So let's see, ADB devices. Let's take this emulator. ADB shell, ADB-S, serial number, shell. Now we need root privileges because certain directories cannot be accessed from the ADB shell context, which is user ID 2000. So we need root privileges. For example, this data directory. Here we get permission denied. Okay, getting root on our Nexus device is no problem. We simply type in SU and we're good to go. Okay, now we can also enter those directories. And within data, I guess MISC, ADB, yes. Yes, here we can see we've got now this file ADB keys. Let's print this out, because this time it's not my private key, of course. This time it's the public key. So if we compare those two, let's do this once again. ADB key pub, yes. Okay, so if we now compare those two, let's do this real quick. Let's print out once again. There we go. Then we can see these are identical because the public key is being stored on the device, and by having the private key, we can verify that this connection, everything works fine. Cryptographic magic happens in the background. If you are interested in this topic, I will explain this in the HTTPS section, how asymmetric cryptography works, okay? Right now, starting this course, we are not interested in doing some cryptography. Alrighty? Yes, okay. So we have also seen this one, and I guess let's have finally a look into some useful commands of ADB, and then we are good to go. I hope this video hasn't become that long, but yeah, let's see that I do not miss something. Oh yes, ADB forward and reverse. But first, let's have a look into this one. Yes, let's pull the smartphone a little bit more right. Okay, let's scroll up. Let's see what do we have here. Yes, we've got a lot of commands. So this is the serial commands, things we have already seen. Okay, devices, also something we have seen. Connect, also forward and reverse. We will have a look into a reverse example. All right. Yes, file transfer, push and pull. This one is important. So if you want to interact with this device, we need to push and pull files to it. So up and download files to it. And this can be done with push and pull. So for example, let's see. This is a test. So now we have created a new text file. Test. And if you want to upload this to our smartphone, we can use ADB push test. This is our local file, and now we need to specify the destination where we want to upload it. I make this a little bit larger, then you can see it better. Okay, so the only two directories which are available on the smartphone, which can be accessed easily from our host system without root privileges, are the SD card and the temp directory. The SD card is the more interesting one because this one holds all your photos, videos, music, downloads, all this kind of stuff. And this is it's a public available directory, so we can use this. By the way, do not get confused by SD card, the name. SD card, it's not a physical SD card. SD card is the eMMC, which stands for Embedded Multimedia Card. Yes, this way. So this is simply just a chip which acts like an SD card, and therefore it has this name over here. Okay, so it's not a physical SD card. This one is your internal memory of the smartphone. All right. So this is the way to upload this file. And once again, if you're just having one device connected, then it's a little bit easier. But now we have to use -s and then the file we want to upload. Oh, sorry, the command push, and then the file we want to upload, and then the destination where we want to upload it to. Okay, 3, 2, 1, push. Okay, if you're now performing ADB shell, once again, I guess I will unplug it in just a moment. So let's see. Okay, I really will unplug it in really just a moment. So now we are on the emulator, and within the SD card, yes, we can see we've got now this text file. Let's print it out. Okay, if we now want to download a file, for example, this gray PNG, we can use ADB pull. Let me clean this up a little bit that you can see it a little bit better. Okay, so now let's see. Let's make a new directory. Oh, there's already one. Let's go into this one. Okay, let's delete those old bug reports. Okay, now we want to download a file which exists on the smartphone to this directory over here. Okay, and therefore we can use ADB pull, and now we have to define the source, which is now the file source on the smartphone. So In this case, it's within /SD card. And then this one, for example, gray PNG. And now we need to define the destination where we want to download this file. In this case, it's the current directory. Once again. Okay, let's repeat this whole command. Okay, let's open the directory. There we go. So now we have downloaded a file from the smartphone to our system. So this is super handy and we will use this quite often during this course. So the SD card is some kind of free zone where we can store files and up and download from them from the host system. All right. Okay. Back to the help. Let's see. Okay, push and pull. Install, something we have already seen. This is the way to install applications. Bug report, also something we have seen. And Java debug wire protocol, this is something we will handle in the debugging session. It's pretty at the end of this course. Loghead. This is also pretty important. So the loghead, it's the device log. And this is something you should keep open all the time during an analysis of an application. So what I do is running loghead, then opening the application, playing around with this one. And after shutting down the application, I will close this loghead. So I will store this into a separate file and then investigate this. You will find a lot of useful information in there. For example, user credentials, API tokens, or you get also assist if you want to circumvent some security features. For example, certificate pinning. If the developer has implemented such a security feature, sometimes some useful information being printed out to this device log, and this can be absolutely helpful in bypassing it. Sounds crazy, and to be honest, it also is. Also things like user credentials or token. Those information shouldn't be stored in the device log, even if it's not possible anymore to read this out by third-party applications. Okay? All right. Then Verify, but this is just for user debug builds. Keygen is generating a new public-private key pair for our ADB. Let's see. Sideload. Okay. Reboot. This is maybe also cool. We can use reboot to boot this device into a certain state, for example, into bootloader or recovery. This is super handy if we perform some rooting of this device, because we can boot this into the bootloader and then flash certain partitions and boot from them afterwards, if those security features has not been enabled. So we need to unlock things like this. But this will wipe data from the device and make things complex. Okay, so you can play around with this one, but you need to be very careful that you do not break your device. Alrighty? Okay. I also provide you some additional information in the cheat sheet. So there you will find an, let's say, most likely safe way to perform some actions. Okay. And then we've got ADB root. So this was a thing, I guess, 10 years ago. So we can use ADB root to restart the ADB daemon with root privileges. Let me show this to you. So what I do right now is I unplug this device and I also power off the virtual machine, that it's getting a little bit more easy. Okay, so now we should only have one device. Let's see. Virtual machine seems to be still powered off, but yeah. We can also do ADB kill server and then ADB shell once again. All right. This will automatically start the server and we can see perfect. We are now connected to this one. Whoops, sorry. Okay, so if you're now doing an ID, we can see we are accessing the ADB shell as UID 2000, which is the shell access. All right. If we now execute this command ADB root, then we can see the ADB daemon on this device will be restarted with root privileges, which means if we are now doing an ADB shell, we instantly have root privileges in this one. At the first view, it seems to be not a big deal because we had root privileges anyway. We could connect to this device and then perform SU and execute our command. So yes, this is possible. But having this ADB daemon running as root enables some more convenient options. For example, if we directly want to pull an file which is within the data directory, for example. If we are not having this ADB daemon running as root, we cannot execute this command directly from our host system. we first have to log in, getting root privileges, copying this file to the SD card, and then downloading it from the SD card. So 3 or 4 steps are being involved during this process. Having the ADB daemon running as root, we can simply use it directly from our command line on our host system. So this makes things a lot easier. But it can be also a little bit tricky sometimes, because having certain detections like root detections, this is something you might overlook. So therefore, I'm not going to use this during this course, but feel free to do this, to restart your ADB daemon with root privileges, then you can directly access those files. Okay? All right. Then let's see, let's clear the screen. ADB help once again. Okay, logcat root. Here we can see restarting the ADB server with USB or TCP IP, but this is not really required. If you're performing in Connect, it's automatically switching to TCP IP. Kill server, also something you have already seen or seen right now. This simply restarts the server, and this is the most recommended troubleshooting guide. So if you encounter some issues with ADB, simply run ADB kill server and then ADB shell once again. So restarting the server, turning it off and on again resolves so many problems. In case if you still encounter some other issues, I have provided you a whole list about errors and their corresponding solutions in the cheat sheet. So please have a look into this one, and of course you can also write me if you encounter something new. Alrighty? Okay. So regarding to ADB, I guess we have covered most options right now. Let's have a final quick look into the reverse, into ADB reverse, that this topic is a little bit better to understand, because if you have seen reverse, you also get a better understanding what forward means, and maybe also get a better understanding what's the difference between those two. Because for me, it took quite a while until I realized what they are doing. Okay, so let's see. Let's stay in this directory and let's create a little website which we can then forward to this smartphone over here, okay? Enabling and service from our Ubuntu VM to the smartphone requires ADB reverse. Enabling and service on the smartphone to our local machine requires ADB forward. So let's create a site and then let's see how reverse works, and then I guess we're good to go. Okay, so let's create an index HTML, and now I need some insane HTML skills. So doc type. All right, let's run this web server. So Python 3 and then HTTP server. Okay, now we're having an HTTP server running on our interfaces on port 8000, and here we can see perfect ADB reverse, wonderful site. Okay. So now let's make this service available to the smartphone. I mean, it's listening right now to all interfaces, but we could also limit this to localhost. Okay, how can we do this? Well, if we're using ADB reverse and then TCP, because it's a TCP protocol, let's say 1234 and then TCP 8000. Yes. And this means if you're making a connection to localhost on the smartphone on port 1234, this one will be reversed to this one. So it will appear on our smartphone, this web server which is running on port 8000. Okay, let's see. We've got no browser, but we've got a web view. This should also work. Okay, let's open HTTP 127.0.0.1 and then 1234. So this should print out our website, which is running on our Ubuntu VM to the smartphone. Let's see, 3, 2, 1. Yes, I already see those requests, and we can see reverse, and we have no title, but we can see yes, this is the page. So this is what reverse means, and forward is simply the other way around. Forward enables a port or service which is available on the smartphone to our system over here. Okay? All right. I know it already got late, but let's sum this up with a short slide, and then you finally reserve your first build. Okay? So let's do this real quick. Okay, here I have summarized some important commands. ADB install to install an application, push and pull to interact with files on our local system, uploading them to the smartphone, vice versa. ADB input touch, something we have already seen. What is also pretty cool is ADB input text and swipe. So ADB input text will automatically fill out this form field with the text we provide via this terminal. ADB logcat, something you should always keep running during your analysis. ADB shell, IP, and so on. I mean, that's a shortcut if you want to easily retrieve the IP address from the virtual machine. Bug report, also something we have already seen and which is also pretty cool. I mean, that's the easiest way to get the HCI Snoop log file, so the Bluetooth Low Energy log, from this device for many devices. ADB connect if you want to make an TCP IP connection, so Wi-Fi for real devices or our virtual machine. And also ADB backup. This one will back up our applications, any corresponding data in there. It depends on the developer what is being included, but sometimes this can also lead to security issues if you can simply fetch the secrets of this user account based on a backup. Alright. Now, after all your patience, I'm absolutely grateful and I'm super happy to provide you your first badge. There you go. Oh, there you go. So this is the end of our installation process, and from now on we will do some really amazing app hacking. And to be honest, we have already seen some cool tricks, so the touch or Bluetooth Low Energy, but the next things, they will be way cooler. So this is something I definitely promise to you. Alrighty, so I'm looking forward to see you in the next chapter.